let's see if we can find area of this pentagon. We know how to find area of triangles and area of rectangles, but how in the world are we going to find the area of this figure? Well, let's see if we can break this apart into triangles and rectangles, and there are a few different ways we can do this. So we'll look at a couple of those. Well, I'm going to go ahead and I'm going to start by putting a line here. I'm going to decompose right here because I would like to look at this triangle here. Okay, so now I have two figures. I have a triangle and a trapezoid, and in 6th grade we do not know how to find the area of a trapezoid using a formula, but we do know how to find the area of triangles and rectangles. So I think I could use that knowledge to help me here by adding a couple of more lines and decomposing just a bit more. So I'm going to go ahead and do this, and then let's take a look at what we've got and see if we've got something we can work with. Now, I think we can handle this. 1, 2, 3 triangles and a rectangle, and we have everything we need to know to be able to find area of that rectangle and those triangles, right? So remember, we can go ahead and we can find the area of this rectangle by counting the number of square units in a row and multiplying by the number of rows. So in this case, we'll go ahead and do a little bit of notation here. We have 3 square units in one row, and we have 3 rows. So we have 3 times 3. 3 times 3 is 9 units squared. That's the area of our rectangle, okay? Now, what can we do to find the area of the triangles? So we've talked about before composing rectangles around the triangles. So we're going to go ahead and do that. All right, so let's take a look at the first one here. So I now have a rectangle composed around this triangle. And how can we find area of the rectangle? Well, we can multiply the length times the width, or we could count the number of square units in a row and multiply that by the number of rows. So in this case, we have 1, 2, 3, 4, 5 square units in one row, and we have 2 rows, so 5 times 2 would give us the area of 10 square units for the rectangle, right? So I'm going to go ahead and label this here. So 5 and 2. 5 times 2 is 10 square units for the rectangle, but we're trying to find the area of this triangle. And what do we know about the area of the triangle? Well, the area of the triangle is half the area of the rectangle. Let me draw a little dotted line here so you can see what I mean. If I were to split this triangle here down the center, you'll notice that we now have 1, 2, 3, 4 congruent triangles, and 2 of those make up this larger triangle. So 2 out of 4, 1/2. So the area of this triangle is 1/2 the area of the rectangle. You all said the area of the rectangle is 10. 2 times 5, 10 square units. And divide that by 2 is a total of 5 square units. 10 square units divided by 2 gives us an area of 5 square units. All right, so now we have the area of this triangle here, and we have the area of this rectangle here. But we still have 2 other triangles that we need to work with. So I'm going to go ahead and grab some lines again, and I want to compose a rectangle around this triangle here. And then I'm going to do that again. And let's see here. All right, so now we have a rectangle composed around this triangle. How can we find area of this rectangle? Well, we can multiply the length times the width, or we could count up the number of square units in a row and multiply by the number of rows. So we have here a length of 3 and a width of 1. And 1 times 3 is 3. But what portion of the area is covered by the triangle? Well, half of that. So we have 3 square units is the area of the rectangle, and half of that is the area of the triangle. So 3 square units divided by 2 is 1.5 square units. Now, what do you notice about this triangle and this triangle? Well, they're exactly the same size, right? So we have 3 by 1, and if we were to come over here, we would also have 1, 2, 3 by 1 would be the dimensions of that rectangle. And the triangle takes up half the area of the rectangle. So the area of this would also be 1.5. We've got a lot going on, so I'm going to go ahead and get my arrows pointed to the correct places here so we can kind of be organized. So let's talk about what we've got here. We have 5 square units for the triangle at the top. We have 9 square units for the rectangle. And we have 1.5 square units for each of the small triangles. Now, how are we going to find area for the composite figure? How are we going to find area of this polygon, of this 5-sided polygon or this pentagon? Well, we're going to have to add all of these areas together, okay? So I know that 1/2 plus 1/2 is a whole. And I've got 9 and 1 is 10. So here's a 10, and 5 is 15, 16 plus that whole. There is an area of 17 square units inside that pentagon. Okay, so just to wrap up, when you're working with composite figures, no matter the type of polygon you're working with, you can decompose that into rectangles and triangles. You can find the area of your rectangles. You can compose rectangles around your triangles, find the area of your rectangles, and half of that will give you the area of your triangles. And then we put all of that together, add that up to get the total area of our composite figures.